Hi, welcome to my YouTube channel. In this video, I shall demonstrate the procedure involved in computing correlation coefficient denoted by small r in SPSS. Correlation coefficient is a specific measure that quantifies the strength of linear relationship between two variables. Correlation coefficient can be any number between +1 and -1, and strength of relationship increases as the number reaches closer to +1 or -1. Moreover, you must know that correlation between two variables does not posit any of the two variables as independent or dependent. Rather, it shows the linearity and direction of relationship only. So, this is the SPSS sheet in which variables have already been computed. So, you need to click on Analyze first. You will see a pop-down window. Click on Correlate, followed by Bivariate. It will show another window in which one box is blank, another carries the computed variables. You need to shift the computed variable into the blank box. So first variable that we are going to shift is effective commitment. Select this variable, click on this arrow, it will automatically be shifted into the blank box. We need another variable. We have selected organizational performance. Again follow the same procedure and shift this variable again into the blank box. Again, you need to check certain options. First, check the Pearson correlation. Followed by two-tailed test of significance. Check this circle also. And in the end, also check flag significant relationships. Then you have to click on the box which shows OK. It will take some time before it is processed. So here you are with the final output. In this table you can see certain values. First of all, you can see this one which shows the perfect positive correlation between effective commitment against itself. So it has to be one which is perfect positive correlation, which is possible only if a variable is tested for correlation against itself. Now, this value of 0.587 is the correlation coefficient for which we were looking for. As I told you that as the values reaches closer to +1 or -1, they are considered as stronger value. So hence, in this case, it is almost 0.6, or precisely speaking 0.587, which is pretty strong value. So this value alone is not sufficient. It has to be significant also. And for that, you need to go through this line, which states that correlation is significant at 0.01 level. And in our case, the value of significance is 0.000, which is far below the level of 0.01. So the result is highly significant. Again, you can see against n, there is a value of 303, which shows the size of sample. Here I come to the end of this tutorial, and I'll be back soon with a new video on new topic. Thank you very much.